Hello guys, and welcome to this new Python tutorial. Today we are going to talk about another type of data structures, which is sets. A set is defined as a unique collection of unique elements that do not follow a specific order, which means that we don't use indices as lists and tuples in sets. It is iterable, which means that we can use a loop to print our elements inside the set. It is mutable, which means that we can add, we can remove, and has no duplicates elements. So it does not allow to have duplicates inside itself. Sets are highly useful to efficiently remove duplicate values from a collection like a list. As we have seen, in a list, you can have duplicates or more than two elements inside a list. So to know the unique elements of this sequence, we can use a set and convert it. Thus, we will get out of the duplicates. Sets also are useful to perform common math operations like unions and intersections. To create a set, we use the curly brackets. So we call, for example, set1 equals to, for example, we get a set of numbers. So 1, 2, for example, 3. Okay, use type function to know the type of your data structure. So it gives you a set. We use the len to find the length of the set, which is 3. Set 1, 0. Set object is not subscriptable. Okay, so as we have said, we don't have index for this element or this one or that element. Okay, also it is unchangeable, which means that, for example, if you want to change this element to, I don't know, for example, we call it 4, we cannot do that. Okay, because this set do not support item assignment. Okay, and also if you want to create an empty set, we cannot use directly the curly brackets as we do for the list. For example, we use directly the square brackets, or in tuples we use the parentheses, but here if we use directly the curly brackets, we get the type as a dictionary. Okay, so if you want to create an empty set, you use directly the set function. Okay, so write set, and here we have the type, which is a set. Okay, and the length, which is an empty set, so it will give us 0 as the length. Okay, so this is about creating sets. We said that they are unordered, which means that we don't have indices, and also we use the type and the length function as lists and sets and tuples, sorry. So for example, if you want to create a list, sorry, we cannot use the keyword list1 equals to, for example, 1 2 3 1 1 1 1 3 4 5, for example. Okay, and you want to know the number of unique elements inside this list, so we can use this set list equals to set list1. Okay, so if we want to print the unique elements of this list, we will get directly 1 2 3 4 and 5, so it will get out of the duplicates. Okay, so this is one way to know the number of unique or the unique elements inside the sequence. So we are going to copy that, for example, set1. Okay, and we want to loop through this set. So for I in set1, we print the I 1 2 3. So as tuples and lists, we can use the for loop to iterate through the sequence or over the sequence and print our elements. So as we have said, we can have any data type if we want inside set. So we have, for example, 1, 2, 3, sorry. So 1, 2.5, false, true. We can have, for example, another tuple. Okay, so for example 1, 7. Okay, so it will create this set type set 4. So we have a set, but if we try to have another set, for example set 1 equals to, we try to copy that, copy first, and we change this to list, so it will generate for us an error. Okay, and also if we change it to set, call it 6. Okay, so call it set, and we change it this one, we'll get also an error. So we can only have a tuple inside set. Okay, so this is about the data types inside the set. For example, as we have created in here, so I will just copy that, copy, paste. Okay, so we call it set 1 and we call this set 2 equals to, for example, 1, 2 and 3. Okay, for example, if we want to add an element inside the set 1, so we just can write set 1, okay, dot add. For example, we add number 4. Okay, and we have here set 1, it will be added anywhere because we don't have an index. Okay, so it will automatically add it to the first element that we have. If we want to try something else, so set 1 dot add 5, for example. Okay, and we print set 1, it will add it directly to the first element. Okay, as we have seen in the lists, when we use, for example, the append, it will add it, we add to the last element of the list, so the last index. But as you can see in here, it will add it to the first, so it will put it from the left to the right. Okay, and if you want, for example, to add all this set to this set, we can use the update. So we write set 1 dot update, update, and we write set 2. Okay, so it will update set 2 into set 1. Okay, so for example, we can also use the union function. So we create set 3 equals to, for example, 4, 5, 6. Okay, and we do set 1 dot union, so which means that we add the set 3 into set 1. Okay, so we have 1, 2, 3, 4, 5, 5, 4, 1, 3, 2. Okay, 5, 4, 1, 3, 2, 1, 2, 3, and we have added the 4, 5, and 6 into our set 1, for example. Now, if we want to remove elements, okay, for example, we want to remove, I don't know, for example, 3. Okay, so we write set 1 dot remove, and we write 3. Okay, so if we print set 1, it will give us 1, 2, 3. Oops, sorry, because I had to, normally it would directly work. Wait, set 1 dot remove 3, so it does not exist. and when we print set1, okay, so right here set1 equals 2. So if you want to print set1, okay, 1 2 3 4 5 6, and so we have removed 3. Now we want to remove, for example, 4. Okay, so set1, it will have 1 2 3 4 5, so 4 5 4 1 1 2, sorry. So we have removed the 4 and we remain by this last set. So this using the remove, and as we have said, set1 dot remove 3, okay, it will generate for us an error if 3 does not exist, okay. But we can use the discard. For example, we will remove 1, okay, so we say that set1 dot discard, okay, and we write 1, okay, so 1 is removed, has been removed. But here, if we try to remove 1 again using the discard function, okay, discard, and we write 1, it will not raise an error for us, okay. So discard and remove do exactly the same thing. Just remove if the element does not exist inside the list, it will create for us an error. Whereas discard, it will not generate an error. So if we replace it by remove, so we'll have an error. Okay, this is the main difference between remove and discard. And we can also use the pop function. Okay, set1 dot pop, and it will remove for us 5. Okay, since we don't have an index for any element inside our set, so pop, it will not, for example, like in a list, it will by default remove the last element of the list, okay, because we have the index of the last element. But here, as you can see, 5 is not the last element, but it has been removed by the pop. So it will choose any element or any item inside the set and it will remove it, okay, because we don't use indices. If you want to, for example, to clear a set, okay, use set1 dot clear, and here we will get set with no items, okay, so length of set1 is 0. And we can also delete using the del function completely the set. So if you call set1, it will say name set1 is not defined. So this is to clear, to remove all the items inside the set and to get an empty set. But the del function, it will directly remove it from your program. So when you try to call that, it will say to you that it is not defined. So for example, if we create my set, create my set1, for example, equals to let's say 1 2 3 4, okay, where are that we call my set2 equals to, for example, 0 1 2 3 4 5 6 7 8 9 sorry 10, okay. So we can do the intersection. For example, if we want to know the duplicates inside the two lists, so the elements that are present in here and in here, we can use the intersection function, okay. So we write, for example, my set2 dot intersection my set1, okay. So we have the intersection between set2 and set1 is 1 2 3 4, okay. These are the elements that are present in both the sets. But if we use symmetric difference, okay, it will only keep the elements that are not present inside the two lists. Okay, so for example, if we write my set2 dot symmetric difference, okay, symmetric difference my set1, it will give us the elements that are not inside the two lists. So this is mainly union minus the intersection. Okay, so union, it will create 0 to 10 minus the intersection, which is 1 2 3 4. Okay, so it will give us, so symmetric difference will give us the elements that are not present in both sets. Okay, and there is also my set1, my, for example, set1 dot is subset of my set2, for example, my set2 true. Okay, because my set2 is or contains my set1, so my set1 is a subset of my set2. Okay, so this is all for the sets. I hope that you have learned new things. Thanks for watching and see you in the next one.